at 8 o'clock. We don't wait for people. We already noticed. I already sent out a notice for them to get in, okay? But anyway, let's get started. So today we are going to talk about the string tuple list. This is the last chapter for Brief Python, okay? The purpose of Brief Python is we only offer you 4 weeks short course to learn basic Python. And then we are going to have another 8 weeks on Python for data science. So we are going to move from the brief Python to Python programming essential course. We'll give you a new course shell. Okay, so it will be a new set of the homework and everything in a new course. But today we are going to finish up this brief Python for the last chapter. So this is last chapter. Liana, how are you? So this last chapter is on data collections. So data collection, what is data collection? Okay, data collection is when we actually work on the Python, we talk about the basic data type. The basic data types are numbers, okay, numbers, and then logic, and then text, 3 different formats, okay? And number, you have integer. It's not good, okay? Let me clean it. It's actually not really good. Let me type it, okay? So numbers, so number, actually they are integer and the float, two different types, okay? And then the second type of the data that's called logic. So it's a Boolean type. And they are true and false. Third type is string. Sometimes we also call it text or message, okay? So these are single character. Sometimes we call it single character, but character and string, no difference. Okay, no difference. So these are the 3 basic data type in Python. Okay. Now today we are going to talk about totally different things. We are going to talk about the data collection. So the data collection in Python, including quote, single quote, double quote, triple quote. These are for strings, okay? Then parentheses, these are for tuples. Then we have bracket, bracket, okay. I'm sorry, bracket. I'm sorry, this either is a special character or something. Kind of deleting. Okay, let me put the list first. And then type this. Okay, I'm not sure why when I use single space, it will be deleted. Okay, and then list. And the last one would be set. And then the very last one would have this one called dictionary. Okay, so today we are going to talk about these 5 different types. That's actually called data collections in Python. Okay. So data collection in Python, you basically just need to remember the different quotation type. So string would be single quote, double quote, or triple quote. Tuple using parentheses, list using brackets, set using curly brace, dictionaries, curly brace, colon, curly brace. Okay, so these are the basic data type you need to remember. So these are compound data type you need to remember. So here are the basic data type: number, logic, string, and in combination you have string, tuple, list, set, and dictionary. So these are what we will cover today. Okay, string in chapter 2, we already talked about it. It's a collection of the characters or letters. Okay. So let's get started from string again. So let's get started from string again. Okay. Okay, so string you can have a S equals single quote. Inside the single quote, you put A, B, C, D. That's fine. Okay, you use that to build a string, that's fine. And then S1 means B. Okay, this one's B later because your string starting with A, B, C, D. This index is 0, 1, 2, 3. So your 2 is this one, it actually is B. Okay, so this is the indexing for string that we talked about it already. And if you use a double quote, that's also okay. S equals double quote A, B, C, D is the same. It's exactly the same. Single quote, double quote doesn't matter. Okay. There's only one thing that may matter is that when you actually say, let's assume that you have a S, and inside you use a single quote, outside you use double quote, inside you use single quote. Then you print this as it will be a string of 2 single quote mark. If you do a single quote inside you put double quote, then it is a string of double quotes. These are special notations. Any questions so far?
No.
No? Okay. No, that's actually next one we are going to talk about the range function. So range function, you have 3 numbers. If you say range is 3, 2, you create range from 0 to 2. So range from 0 to 2, this one is the so-called range object. Okay. So you can basically say convert. You can actually type range object. So range this it will tell you is actually a range object. Okay. So range object you can convert it to tuple. So you can do tuple range of 2. So range of 2 is a range from 0 to 2. You will create 0 and 1 tuple. Okay, this is a range function. So range actually you may have 3 numbers: starting number, ending number, and jumping number. Okay, starting is your starting number, ending is your ending number, but not including. So that's assume that you have a range of 1, 10, and 2. You start from 1 and then jump by 2. So you 1, 3, 5, 7, 9, and then 11. 11 is over 10, so it's not included. So you will be creating something like this. Okay. So basically, you can do tuple of the range of 1 to 10 and then jump by 2. You give you this 1, 3, 5, 7, 9. Okay. So range tuple is actually a collection of data. In this case, it's a collection of integers. Okay. String is a collection of text. Okay. So string you can create by using this. Okay. Next one, let's actually look at the string functions. Okay, I'm sorry. Next one, let's look at tuple. Tuple, we have a T1, 2. Okay, this is a tuple 1, 2. Okay. So it's a 2-value system. We call it a tuple. Okay. 2 values. You have a tuple. So if you want to have a tuple with only 1 data, say only with 3, you cannot use a list with 3. That's wrong. That will not give you a single tuple of the P. that will give you a single 3, because T in this case, you will evaluate the parentheses and you get a number 3. So T is a number 3 in this case. It's not a tuple. It's an integer. Okay. So if you want to have a single element tuple, you should put a 3 comma and nothing. 3 comma and nothing. This actually, if you type T, it will be a tuple. And you bring the tuple, it will be 3 comma. So single element tuple, you have to put the single element followed by comma. This is single element tuple, okay? If you just put a 3, that will be considered just the 3 number with parentheses. You evaluate only with 3. It is not a tuple. And if you have a 3 comma 2, that's a tuple of 2 values. Okay, and you may also have a tuple of 4 value, 5 values, such as P equals 1, 2, 3, 1, 1, 2, 3, 4, 5, 6, 7. Okay, print tuple. And then you can also print tuple 2. That is 3, that's index 3. So tuple also share the same index system of 0, 1, 2, 3, 4, 5, 6. Okay? Is that okay?
Yeah.
Yeah.
So string is a collection of the characters. Tuple is a collection of number or anything, but it actually is using this. Next one is actually we call it list. So we say a list equals 1, 2, 3, 4, and we can print a list. Type of a list. It is a list. List using bracket. So now the question is, I have a 1, 2, 3, 4, and I have a bracket of a 1, 2, 3, 4. So what is really the difference between tuple and list? They look so much the same, and then it's also each one of them is a multiple value data collection. So what really is the difference between the tuple and list? What is the difference between tuple and list? This one for Jeff Benjamin. What's the difference between them?
Wait, what the hell's the top thing supposed to say?
What's the difference?
No, is that supposed to read tuple? Forget. Table. I think one doesn't store the values as well. So,
You supposed to finish the Python before, right?
yeah.
Yeah. How about Belinda? I mean, I'm just trying to figure out whether you remember it or not.
Well, like the list, you can change the values, and then the tuples you can't.
Yeah, tuple is immutable. Tuple you cannot change the data. List you can change the data. Deanna, do you understand this? What we are talking about?
Yes.
So immutable means you cannot change. So tuple is immutable. It means tuple cannot change. Tuple you cannot change. So basically, I have a tuple equals 1, 2, 3, right? So can I do tuple that say append 4.
No.
No, that's wrong. But if I have a list equals 1, 2, 3, 4. 1, 2, 3. Okay, 1, 2, 3. May I do a list that append 4? And then put in my a list again. I append it, so I add the 4 into the list. So basically, list you can delete, you can add, you can insert, you can pop, you can do surgery on it. That's list. And tuple you cannot. Tuple you cannot. Tuple is fixed size, you cannot. So tuple in a way more like a array in Java. And then list more like array list. And its name is list anyway, right? So it's a list. List means that you have a flexible length. Now you can change the size of the list. And tuple, no, you can only have the fixed size. You can change it by redirection, okay? You can do this, you can do t equals 1, 2, 3, and then t equal 1, 2, 3, 4. Can you do that? Yes, but this is called redirection. Redirection means that you originally have 1, 2, 3 tuple, your t pointing to it. Then you point into a new 1, 2, 3, 4. You kind of delete the link right here, you point into a new thing. But in terms of the data, you actually do not change the data by adding this. No, you do not. It's pointing to a new thing. This is called redirection. This is not really appending. So tuple is a data collection that you cannot change its size. Okay. Next one, we are going to talk about set. Right now, I'm just going over every type. Okay, every type. Next one is set. So set is different from list as well. So let's assume that my list is a list equals 1, 2, 3, 2, 3, 3, 1, 2. Okay. So list is a flexible size, and this also allows duplication. Some element of the same data is okay to be put here. Okay. Then now, if I have something called a set, it is 1, 2, 3, 4, 2, 3, 3, 4, 2. Then I print my a set. Set but not allow duplication. So this one got deleted. Only one copy left. Okay, so these are the main difference between tuple, list, and set. Set is no duplication. List allow duplication, allow flexible length, allow change. Tuple doesn't allow flexible change, doesn't allow changes, and it allows duplication. Any questions so far?
No.
Okay, so these are the difference between these different data. The last one we are going to talk about is dictionary. Okay, so dictionary is D equals name Okay, so I create a dictionary. This dictionary is a person, a student. So the name of this person is Eric. So this is one string, colon, string, colon, string, colon, string. And then age is the first value, colon, 12. This is the integer, so it's a string, colon, integer. Next one is GPA. It is 3.4. So it actually is a collection of key, colon, and value. Key and value, key and value, key and value, key and value. Key is a data field name. Value is value. So name is Eric, age is 12, GPA is 3.4. So this is kind of a data collection. We have key value pair, key value pair, key value pair. We call it dictionary. And dictionary is very useful. In Java, we call it map, okay? But here we don't talk about map, okay? In Java, we call it map. But basically, it's a key value pair, key value pair, key value pair. Any questions so far?
No.
No? So this is a key value pair is very openly seen, okay? In JavaScript, we also have the key value pair as the object, okay? We'll talk about this dictionary later, but so far we cover the string, tuple, list, set, and the dictionary. Okay, these are different things that we cover in today's talk. Okay, so basically we are learning the data collections. And then this one is a collection of characters, tuples. Let's look at tuples. So tuple, if you have a tuple equals character A and 1 and 3.4. So can you allow the tuple of mixed data type? Yes, it's okay. It's okay to have a tuple of mixed data type. Can you have a list of mixed data type? Yes, you can have the list of mixed data type as well. Okay. Can you have a set of mixed data type? Yes, you can also have a mixed data type for the set as well, also for the dictionary. Okay, so these are different data collection. It just show you how you can combine data. Okay, as for what data they are combining, it's very flexible. Okay, you can basically put in numbers, logic, and character in any combination that you like. Okay. Any questions so far?
No.
No? If no, then we are going to the string again to look at the functions, and then we are going to look at it one by one, okay? So today we are going to continue our talk starting from string. So that's actually creating a new file. And we are going to save as so this one we will call it chapter 4. Chapter 4, here we actually work on string number 1. String number 1 is the creation of the string. Creation of the string, you use a single quote A, B, C, D. You use a double quote A, B, C, D. You use a triple quote, quadruple quote A, B, C, D. These are the same. They mean the same thing, okay? But we don't actually talk about this right now. Let's look at another one. Let's call it alphabet. So alphabet, when I want to create a string for my A to Z alphabet, then I may have a stupid way to do it. A, B, C, D, E, F, G, H, I, J, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, S, Y, Z. Okay, if I create something like this is actually very dangerous because I may mistype some character, I may miss some numbers. So this actually is okay, but stupid. So how can I create the alphabet string without putting in every single one? So let me have the alphabet, right? Then I will create a list. So this list is a character of a number I for all I. Okay, let's call it ASCII. So we will create ASCII code. For all ASCII code actually in range from 65 to 91. Because you want to go from 65 to 90, but not including 91, okay? So this will create a list of 65, 66, 67, up to 90. Is that okay? And then we will convert this different number. So this one will create a tuple of this. Then you will convert the ASCII code 65 to a character. So the whole thing eventually will become A, B, C, like this. This we call it, this kind of the list we call it comprehension list. So instead of giving each examples, each numbers or each letters, you use a for to create every single items for every ASC in the range of 65 to 90. Now create number from 65 to 90. And then that number will be converted to character. CHR is convert the number of ASCII code to a character. And then the whole thing is basically a list. So we do once we do double quote, join. We join this string together. Then that's it. That's agent print alphabet. So you'll be A to Z. Okay, so this one is a little bit more difficult. Any question here? Any question here? Anybody has trouble understanding this?
No.
How about Ian, are you okay here?
Yeah.
So this list, we basically creating a list of A, B, C, and then we join them together. So now let's look at this join. So this join function, if we join with the plus sign, let's see what happens. Then it's A plus B plus C plus, in the middle, we actually use a plus sign to join them together. So join function means, this one means the list got joined by the plus sign. got joined by the plus sign. Okay. So this one is alphabet, uppercase alphabet. If I want to generate a lowercase alphabet, let me copy this one. Let me copy the whole thing. Put it over here. So let's actually call it alphabet lower. Then this one I start from 97 to 122. Okay, this is ASCII table. And then here we print out ASCII code lower. So the ASCII code, I talk about it, okay? If you don't remember that, you have to review it, okay? Something wrong? It's 97, not from 67, 97. I want the lowercase only. Okay, sorry. 67 is, okay, so this is A to Z in lowercase. So these are the way we create a string using comprehension list. Any questions so far?
Oh,
Let's assume that sometime you want to create something called DNA. So let's call it DNA. Let's call it genes. So Belinda, what is ATCG? But Belinda, are you okay? Can you answer? I know you say that your microphone may have some trouble. Okay. So how about Liana? You learned the biology before, right?
yeah.
So what is ATCG?
It's the nucleotides.
Yeah, the nucleotide. Yes. So why we have 4 nucleotides? What's the purpose of nucleotide? Your genetic code actually is coded in the ACGG, right? So if you look at the XY, this chromosome, okay, whatever. I may not have pronounced it right. You do have a lot of the gene on top of it, and each one of them is ATCG type. So A will map with T, C map with G. Remember that? Remember that or no? You have to remember, okay? This one is very important because if you go to do generic computation research, DNA, ATCG.
Mr. Cho, I can't hear you.
You cannot hear me? Liana, do you hear me?
We can hear you.
Yeah, I can hear you.
So I think that Belinda's microphone has some problem, okay? It is okay, but here you do have this ATCG, right?
Yeah.
This is DNA ATCG stuff. So these are 4 different type of your gene code, and you do biology research. Basically, a lot of gene research, if you do it, is based on this. So they are kind of different kind of combinations. So it's just like the so-called secret code that you have. Okay. And then there is a RNA. RNA and DNA are actually different. DNA is using ATCG and RNA are different. RNA using ATUG or something. I don't remember that, but actually it's different from ATCG. Okay, so it's different. So you do have different strains, and then you actually call your chromosome. Okay, I'm sorry, chromosome. Okay, I actually not really good at pronouncing this. Okay, but this actually is what you will see the ACTG stuff. Okay, let's assume that you are going to do research in biology and generic study. Okay, we want to see any different combination. So we may have a strain. So a strain can be represented as this kind of ACTG strain. So each of the chromosome is actually half of it. So this one is genetic strain. One side of it is called one strain. Okay. One side of it is called one strain. So this one side of it, you do have the. Okay, if it's RNA, I think there is a U. Okay, there's a U. This one is to generate from DNA to RNA. So it's a type 5 strain and type 3 strain. Okay, anyway, you do need to know about this if you do study the genetic stuff, okay? I'm just talking about if you want to do it. So here you have the strain. This strain is actually combined by ACTG. You want to randomly generate it. How can I generate it randomly? Okay. So you will need to have the random number generator. So let's look at the random number generator. So Python random number. Python random number is a built-in random number called random. So you can use the random, or you can use a random integer. Or you can use a random integer to generate it. Okay, so random integer actually have the starting variable to the ending variable, okay, both included. Okay, so let's look at the random integer. It is included in the random module. So if you want to use the random number, you need to actually do import random. So you do install random, you want to use the random number, random integer, you need to do random that random in from 0 to 3. Included, okay, included. So this will be a number from 0 to 3. Okay, from 0 to 3. So you will use this random number as the index for the string of ATCG. Right, so this one is a random number generated. One random ATCG you will generate. So put a string there and then dot a random index from 0 to 3. So this one is maybe A, maybe T, maybe C, maybe G, any one of them possible. But this kind of thing I want to create, let's assume that we create 10 of them. So for I in range 10. And then create this one as a list. So this one would be maybe A, maybe T, maybe G, maybe A again, and then totally there are 10 of them. Since every I, we create one random symbol. That random symbol is picked from this string. So these are totally will have 10 different ATCG things. Now the whole thing joined by empty string that will create a string of 10 ATCG symbols. And that is a random genetic This one don't have a dot. I'm sorry. It's an index for the string. I'm sorry. Does that make sense?
Yeah.
You're automatic. She creating this random genetic. Okay. So you actually will actually look at the ATCG couples. So A always come with, let me see. I'm sorry. So they have A must match with T, T must match with A, G must match with C, C must match with G, okay? So these are default combinations. So A, T, C, G, okay, and it's mapping. Let's create something called so you got a gene, right? You got a gene right here. You are going to create another one that's actually your let's see. Your mapping. So your mapping will be A will be mapped with T, T will map with A, C will map with G, G will map with C, okay? So this actually is one dictionary. This dictionary will give you the right mapping. When you do reduction, okay, you do reduction, you only have half of it. When you try to create a new gene, you will create the other half. So your A would map with T, T will map with A. So that's assume that we have a string and we are going to create its couple. So that's define a function. Reduction, genetic reduction. The other word is called, let me see, reverse of genetic reduction is called genetic duplication. Okay, let's call it genetic duplication. Okay, let's call it duplication. Let's assume you have a strand coming in and then you want to duplicate it. Okay, so you got a strand. A strand is actually a string. You have ATCT string, so you are going to create another one. So let's call it D. This D actually is equal to empty string. Okay, so for each character, for each gene in string, okay, then E will plus equal the genetic map of your gene. Eventually, you will return your D. So let's do string Here let's call it string 5. So I'm going to call it string 3. String 3 is the duplication of string 5. So let's print your string, string 5, and print your string 3. And let's run it. This is basically a string operation. Let me see something wrong. This one should be a count. Here it said that string is not defined. Do you mean string 5? String is not defined. String is not even print. Oh, this one is string 5. Okay, I'm sorry, string 5. I changed it, but I did not change it. So the ATCG automatically mapping to TT. Okay, it mapped it well. Okay. So right here, I already using the string to do DNA research for you. Does that make sense?
Yeah.
So the technique that we learn is the string, dictionary, and the comprehension list, and joining of the string and a function. These are different techniques that we learned so far. Let me review it one more time. So today we teach you how to create a string. You can put the string of different symbol there. That's no problem. Okay. If you don't know the symbols and you want to create it by the ASCII code, you can use the ASCII code to convert it to a character and then that make it a list and then join them together with a string. Okay, and you can create in the lowercase alphabet and alphabet. Okay, and then we work on the genetic study. So gene, you have the ATCG type, and you have the corresponding type in the map. So A type will map to T, T type map to A, C type map to G, G type map to C. So this is so-called dictionary. Dictionary's main purpose is to map one type to the other. Okay, so now you want to create a string 5. String is a one line of the gene to be for 10 different genes. So you do 0 to 3 from here to every time come out with a letter. So totally 10 different symbols, and you join them together, it will become some sort of ATGC, and then totally 10 symbols that we call string 5. So this string 5 will duplicate it to a string 3 because A will map to T, T will map to A, G will map to C, C will map to G using this duplication function. So by doing this, we are already doing DNA research. Okay, so when you go into the DNA research, is that how the combination of ATCG should change your gene, for example, like make you fat, or make it have a diabetic, or give you a cancer. That actually is the decoding of the combination of the strengths. Okay, right? Or this kid has high IQ or low. That's actually in the interpretation of the different strength. But if you want to actually do DNA research and then randomly generating different combination, you can also have this to help you to do studies. So this actually is very popular research field of DNA computing. Okay, and today we use it as the example to show you how strings are generated and being processed. Any questions so far?
No.
Okay, so here we talk about the so-called so here we talk about you actually have A, B, C, D, okay? And we also talk about creation of using A, B, C, D. And then we join them together using join function. So this one is from list back to string. Now let's do string to list. So let's create a new one. So this new one, let's do S equals A, B, C, D. May I do this? Let me create S list equals list of the S. This one is the same as string number 2. And that's wrong. So it convert the string to list. You use this function that can convert it to a list. So same thing, if I do S tuple, may I convert a string to a tuple? Yes, you can convert it to a tuple. Yes, you can. Is that okay? So basically, string is a collection of the characters. It can be converted to list. List can convert back to string using join function. And then list can be converted to tuple. Tuple also can be converted back to list, and string can convert to tuple. Tuple can convert back to string. Any questions so far? Any questions so far?
No.
No.
So these are different combination of the type, okay? So we do have a tuple. Now, let's see. So let's try, let's see, if I have S equals, okay, let's actually do this join. Okay, so this one is creating the alphabet, okay? Okay, we've got the alphabet. So this alphabet, I may want to create I equals index. I would like to check the alphabet of J. Oh, I'm sorry. Substring not found. Let me see. Oh, this one is lowercase. I'm sorry. I'm sorry. Terribly sorry. Okay, so it's 9. So it's 0, 1, 2, 3, the 10th number, but you actually index 9. Is that okay? Any question?
No.
So if you don't find, it actually do nothing, so it will actually create trouble, okay? As you see, if I use a lowercase, it actually, this index function will not find anything. Then you will have a substring not found. Okay, we'll talk about this later, but for the time being, we just assume that here we do have this one. That would require exception handling, okay? But we don't handle the exception right now. So this one is used to find out where this one is, okay? That's the index function. Okay, let's assume that these are something we want to work on. Let me go back to the slices. Next one, let's look at the tuple. So tuple single element, we talked about it already. You need to use 11 comma. Can I use just 11? Okay. And then it's immutable, it's enclosed in parentheses. Okay, this we know. So can you do slicing on it? Yes, you can do index slicing on it as well, just like your string. Okay. So tuple plus equal 44. This one is equal to 1, 2, 2, 3, 3 plus 4, 4. So this plus sign will create a new tuple. It's not modifying the original one. You're actually creating a new one. Okay? Does that make sense?
Yeah.
But you cannot just plus the number layer. Plus the number layer will not be able to add it in, okay? You have to use a single element list to add it in. You can do sorted function, so you can put it into the sorted. You sort it into a new tuple that actually sorted, okay? But that's a new tuple. So let's see, let's actually create a new one. This one, let's call it P equals. So this is tuple of 1. Oh, we are missing 2. Okay, let's put a 2 in there. 1, 2, 3, 4, 5. Okay, this one. And then we can do tuple solid equals solid. Put your tuple in there, and then put your T solid. This one is save as tuple number 1. Okay. But the sorted will actually return a list. So if you don't like list, you can convert it back to tuple. Just be consistent, okay? Just be consistent. We convert it back to tuple. Any questions so far?
No.
Okay, now we can also do another solid. So here you can use, you have the solid, but here you can do reverse equals 3. Capital 3. Capital 3. So reverse equal true, it will give you from large number to small numbers. Is that okay?
Yeah.
Any questions so far?
No.
No? No, next one, let's actually try to have. So they usually tuple, when will we use a tuple? Usually is like a point, P1 equals P2 equals 3, 4, something like this, okay? Something like this, we call it a tuple. So let's see. So let's assume that we do have a x equals 3, y equals 4. May I do this? May I do sum and if equals x plus y? And x minus 1. And then bring my sum and bring my equals. May I do that? So sum equals x plus y. Difference equals x minus y. May I do that? Yes, you can. It's called simultaneous arithmetic. Simultaneous assignment. This assigned to it here is assigned to it here. Any question?
No.
Another way, could I do this if I don't want to have a tuple? Can I do W and U equals S plus Y comma X minus Y without the tuple sign? May I do that? Without the parentheses, is that okay? That also okay. So simultaneous assignment, this is also okay. With parentheses, also okay. So this actually sometimes tuple is very powerful in Python, okay? So let's see. So originally you have a x equals 3, y equals 4. Then you say xy equals swap of the xy. Swap of xy, your b, your y assigned to original x. Your y assigned to the your x assigned to the original y, and let's print it. And they will perform swap. So x become 4 and y becomes 3. Is that okay? Does that make sense? So in a way, your Python can return multiple value. And that's a good advantage. Usually your C language or Java, you can only return one variable. But your Python allow you to return multiple value. And how this multiple value can help you in programming, that's actually up to you. Okay, you have to figure it out. Any questions so far?
No.
So we want to find the GCD, greatest common denominator. Okay. So this one, 48 and 32, okay. Liana, what is the GCD for these two? Graded common denominator or GCF, graded common factor. Liana, hear me? If I ask you what is the GCD for these two numbers, what would it be? Hello, hear me?
4 and 3.
4 and 3. So this one divided by 16, you are 3. This one divided by 16, you are 2. So the GCD or GCF should be 16. Okay, because 48 is 3 times 16. 32 is 2 times 16. So the GCD is really this number. Is that okay? So Liana, how to calculate GCD for these two numbers?
To find
Okay, you may have to study it, okay? How about Benjamin, how to find the GCD for these two numbers?
And GCD, so like the greatest number that can divide both of them.
Yeah, could I find it?
Well, I mean, the most inefficient way would just be to like go through a for loop.
Yeah, how to do for the for loop?
So I guess it would be like what from 1 to 48, and then just so you want to have like a max value, you have a max variable, and then you want to do from 1 through 48 if a number can divide both can divide both 32 and 48, then you set that as the new max value, and at the end you just output the max.
That would took a very long time.
Yeah, I know.
How about Pareto? Do you have any other way to find the GCD?
Mhm.
So the GCD, if you look at it, you do this, okay? 48 divided by 60, 32, you got 1, so 32, remainder 16. 16 actually 32 divided by 16, you got 2. And then you actually remainder 0. Once you remainder 0, this one is your GCD. Okay? So to write a program to find a GCD, you just need this. If n equals 0, you will return your n. Otherwise, you will return the GCD of your. The first one you use 48 and 32. Next one you use 32 and 16. So basically, you use your n and your remainder of n multiplied by n. This will calculate a GCD for you. It's called Euclidean algorithm for GCD. But anyway, you do pass a couple there, 2 value to recursively finding the GCD. Okay, so let's try this one. We actually got this one and we do print GCD of 48 and 32. Print the GCD of 32 and 48. It's both are 16. Okay, so this one will calculate the GCD for you. The idea is that you have n equals, let's assume it's actually 48, equals a times f, n equals b times f. It is equals 32. So if a and b prime to each other, then f will be your GCD. Okay. So basically, if that is true, m minus n is also multiple of the f, since it's multiple f. So it's still multiple of f. Or even m minus a certain number of the n, it should be still a multiple of f. And this thing can be the remainder of n modular by n. It will be remainder like that. So you will actually get this. So the remainder and the n both are multiple of the factors. So originally you find a GCD for m and n. Now you use a m and r. And recursively finding it, you will find your GCD, okay? Any question? A little bit difficult, okay? It's okay, but in AP CSA, you are supposed to know this, okay? AP CSA would teach you this structure for this. Okay, here we don't force you to really 100% understand it. You just need to know that the tuple sometimes can be returned from a function. Okay, sometimes the tuple can be returned a function and it's very efficient. Okay, it's very efficient. And tuple can be used to swap numbers. Okay, sometimes you can use to swap numbers. That's what we learned today. Okay, so these are tuples. Next one, I'm going to talk about, let me see, let me continue the tuple part. Okay, next one, we're going to talk about list. So list is more interesting because list you can do addition, deletion, and all kind of things. Okay, that's actually, let's see, let's actually do this. Let's create a new file. Let's save us list number one. Okay, so we do have the string one, tuple two. Okay, so these are different example file today. So list number one, let's assume that we have a data that is 2, 3, 4, 5. Okay, let's do this. Now the first thing is to pen. So data dot pen 6. That's a pretty. So a 6 is add to the end. Okay. Now if I want to delete this number 6, so I say R equals data.pub. So 6 got deleted, and the deleted element got stored into the R. So far, okay. Hello, so far, okay. So we have 2, 3, 4, 5. You can add a 6 there. You can delete it using the append and the pub. Is that okay so far?
Yeah.
Now, if I want to say, put a number right here with 100. So you have 2, 3, 4, 5. The insert location is index 0, 1, 2, 3, 4. So you want to insert the insert location 2 with 100. So let's do this one. Let's do insert at the index 2 is 100. So let's do data that insert to 100. So we inserted 100 right there, okay? Now, if I want to delete that element at the index 2, okay? So the 100 is at the index 2 location got popped out. So append to the end, pop will delete it at the end. Insert at a certain location, pop at a certain location. Any questions so far?
No.
Next one, let's have the data tool. So we create data 3 equals data 2 equals data plus data 2. So this is a plus sign. Plus sign is two lists plus together. Then we print my data 3. Two are connected together. So this one is connecting the two data together. Okay, then we can also have the data solid equals solid of data 3 and create data solid. We can solid data as well. It's already sorted. Okay, let's do the other way. Let's do reverse. Since solid it already the original data already sorted. Let's do reverse so we will know it actually is reverse sorted. Yes, it got reversed. Okay, any questions so far? So these are basic operation for a list. Okay, basic operation for list. Any question?
No.
No? No, next one we are going to talk about dictionary. Let's talk about set first. So set is very simple. Let's have a list of and you just convert it to a set. Then you remove the duplication. And then you convert it to a list again. So this is usually is actually used to remove the duplication. So the set is a list, but it usually is used to remove the duplication. Okay, because you kind of remove the duplication. Any questions so far?
No.
No, next one we are going to talk about dictionary. Dictionary more difficult, okay? So first you need to know about what is dictionary. So let's do student one course. Okay, so basically you have key column pair value, key value, key value, key value, okay? That's one dictionary. So you can do printing. That's a print your S1. Okay, so this one is one student. But sometimes you can, this actually is by, you actually set up the data already. But sometimes you can do student two equal dictionary. And that's print S2. So at this moment, the dictionary is empty. So you got nothing in there. Is that okay? So this is an empty dictionary. Okay, now your S2 is empty, but S2 will have a name. Let's assume this, and we print out S2. So it looks like an array, but you use the key over here, value over here. Then you could assign a key value pair to the student two. And name Tony. Any questions so far? So you can also create a student two, age. So this way to create a dictionary and this way is the same. Any questions so far? You got the same result. Is that okay? Hello, is that okay so far?
Yeah.
So if I do print S2, what should I get? This one for Brenda, what should I get?
15.
15, yes. Okay. So dictionary is a combination of key value pair, key value pair, key value pairs. Okay. So one way is you can use a listing to list out every data field. That's one way. Another way is that you can put this kind of array structure to do it, okay, one by one, one by one. So let's see, can I do this? Can I do print S2 dot name? No, it is not. This is not okay in Python. But okay in JavaScript. Okay, I just want to let you know this one not okay in Python, but okay in JavaScript. Okay. Okay, now we are key value pair, key value pair. That's actually So there's a function called keys. You get all the key right here. So you actually can do keys. Okay, you can also do values. So this is extracting the key and value from the dictionary out. Any question? Oh, I'm sorry, I need to print them. Okay, sorry. So there's print keys, print values. Okay, so key are here, value are here. Now I can do new student equal zipping of my keys and my values. And that's print. So print this new dictionary out. It's a zip object. So this is a zip object that's actually converted to dictionary up to the zip. Any question? So there's a name, Tony, age 15, GPA 2.8. And then we actually do keys to put this into a new list called keys. And then we use this one to create it into values. And these two things we got combined them together using zip. And zip them together and then convert them back to dictionary. You go back to the original dictionary. It's okay? So it's like you can extract key and value from your dictionary and then combine them back. Does that make sense or no? Hello? Is that okay?
Yeah.
So this is kind of teaching you how to combine the tuple or list into a dictionary. So tuple or list can be combined into dictionary as well, okay? And it can be extracted by the different key and value. You can also do this. You can also do tuples equals the so-called S2 that items. So you do not extract the key or value, you extract two as a pair. And that will be a list of tuple, 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 three tuple, a list. So that's actually converts things into a list. Okay? That become a list of tuples. And your items is extracting the tuples using items. Okay? And so far, okay? So far, okay?
Yeah.
How about Liana? Are you okay so far? Liana, are you okay?
Yeah.
Hmm?
Yeah.
Today is a little bit more difficult, okay? Now we do for each key in S2. We can see what happened. Follow for each key in dictionary. So you print out each key name, okay? And you can also print the S2's key value. That's the value part. The value part. Okay, the value part. Okay. For each key in the dictionary, this is one way you can do it. You can also do for each key in S2 that keys. That is the same. You can also do that. Okay. Okay, so today we go over the different combination of key and value, and also this tuple and dictionary and the string. So these are different combination of the data type in Python. Okay, and then we are going to go over to use this Python language for data science. Okay, starting from the next week. So before the end of the next week, I'm going to give you the new course shell, and we will start to look at the data science part. Okay, and the language part we will continue to teach you for deeper and more function, more things, and we will have more homework, and we will go into the graphic design as well. But that's we are going to add more difficulty later. Okay, but today we are up to here. We basically go over the different combination of the data type, including the string, list, tuple, and also the dictionary. Okay, also dictionary. There are more functions you can look at. For example, like set. There are more functions right here. You can study it. Okay. There are more functions for the list as well, for split as well. We do not have that much time to go over every single functions, but we will go over the list, string, set, and everything again when we go over the data processing part. Okay? Is that okay? Okay. If no question, that's it for today. Okay. See you next week. Okay. Bye-bye.
Thank you.
Bye. Thank
Bye-bye.
you, Mr.
Good
Cho.
night.
Bye.
Bye-bye.